So today's lesson is Victor's intro. So we're now kind of moving into a new unit. If we have time, we are going to go back to talk about trig identities because there's really a lot more that we can do with that. We'll come back to that maybe towards the end of the semester if we have time to. So the rest of kind of pre-calculus, we're still kind of in pre-calculus, we're in lesson number 27 of pre-calculus, right? The rest of pre-calculus is mainly kind of split up into different units that are not really that related to each other. So we're kind of going to be scattered. We're going to do vectors, and then we're going to do something called conic sections, which is like ellipses, hyperboles, different shapes. Then we're going to do something called parametrics, and then we're going to do polar. Okay, all of those are isolated topics. They're not as connected, and most of these topics we're about to get into starting from now on is stuff that is more helpful in BC calculus rather than AB calculus. Okay, just so you know kind of the scheme of maths or the trajectory of math. So most of what we did at the beginning, the unit circle, the trig identities, all of that you will immediately use next year in calculus kind of right away. Then most of what we're learning right now, generally speaking, is going to come from BC calculus, which is going to be what you take after AB calculus. So that's just kind of where we're headed big picture in terms of the content, okay? To start, this kind of connects with what we're doing. So I want you to take a minute on a sheet of paper and answer these two questions. So first, find the distance between these 2 points, however you would do it. And then what is another way? Think about what another way to do it is. So I'll give you a couple of minutes to do that. So let's do distance formula, then we'll come back to the rise over run part, okay? So if we're using this formula, hopefully y'all remember that from geometry, it's to find the distance between 2 points. We could just label this as x1, y1, right? And this as x2, y2. And then if we plug in, y2 would be 6, y1 would be 2, x2 would be 6, x1 would be 3. And you just simplify that. So it'd be the square root of 6 minus 3 is 3, 3 squared 9, 6 minus 2, 4, 4 squared 16. And you get the square root of 25, which is 5, right? So that means the distance, this is 5, the distance between these two is 5. So with the rise over run piece, Brianna, what did you do once you found that this was the 4 here and this was 3? Because that is the other way you could do it, is kind of drawing that triangle. Okay, so she says 3, 4, 5 triangle, yeah. So it's just a Pythagorean theorem, right? Where you can just recognize it's a 3, 4, 5 special triangle, and so that's how you get the hypotenuse. So I want us to remember this because this is going to come up when we're talking about vectors. So remember this distance formula and how we're finding the distance between those 2 points, okay? So I just wanted to refresh our memory on that because that's what we're going to use today. All right, any questions? All right. So here's kind of our calendar. We did a slight adjustment since last class. So we're doing our vectors intro today. We're going to do 4 lessons on vectors. So we'll do the one on Monday, Tuesday, and Wednesday. And remember, I told you that tomorrow we're actually we pushed everything back a day. So tomorrow there will be no Zoom session. You can just use it to catch up on your work. You can do practice from other classes or just rest or sleep in a little bit. I know a lot of the feedback I'm getting is that a lot of your classes, you're getting more work than you would generally in class. I haven't received that feedback for this class, but just in general. And so I want to be sensitive to that. So we'll get a little bit of a break tomorrow, okay? And then Friday, we'll still have our Zoom office hours. So that is if you have any questions about the practice from this week. Your practice will be due Friday at 4:20, and you have 1 practice from this trig identities, 1 from this double angle identities, which are both posted, and then we'll have a practice for today. So it'll be 3 total practices that are due Friday at 4:20, okay? All right, and then the 6 weeks ends next Thursday, so just take note of that. Make sure your grades are where you want it to be for all of your classes, that you're checking in with your teachers, checking PowerSchool. If you don't have access to PowerSchool, just let me know, and I can send you a picture of your grades if you need that, just because you don't have access to printing right now, like I usually would in my class, okay? So, and then you have a 4-day weekend, actually. I don't know if y'all know that, but you have no school on the 10th, and then you have no school the following Monday. So that's nice. So that's something to look forward to there. All right. All right. So we'll go ahead and get started. We'll say our 4 goals. We will learn math, build character, never give up, and ask why. All right. So we're going to continue doing it. All right. First, I want to start with a question. And this kind of is our intro into vectors. What is the difference between speed and velocity? Just based on what you know right now, what would you say the difference between speed and velocity is? And anyone can answer there. So what's the difference between speed and velocity?
Speed talks about how fast an object is moving, while velocity describes how fast, but also like where it's going.
Okay, good. So he says speed is how fast, velocity is how fast and where. Okay. Other thoughts? Anything to add to that? Okay. Speed is a relationship between distance and time. Carla says in the chat. Yes, speed is a relationship between distance and time. Anyone else have anything to add to that? What is the difference between speed and velocity? All right. Yeah, so the main difference is basically what Maria said, that speed is going to be kind of how fast something is going. So think miles per hour, right? Velocity is going to be how fast it's going, but also the direction component is added to it. So you would say you're traveling at maybe 5 miles per hour east. That would be a velocity because you're including the component of direction. Okay. So when we talk about vectors, okay, speed would be considered a scalar quantity, just a pure measurement, okay? Velocity would be considered a vector quantity because it has both measure as well as direction, okay? So when we're talking about vectors, we are introducing not just how big something is or how fast something is, but also the direction in which that something is moving, okay? So we're gonna do situations next week. For now, we're just looking at the mathematical aspects of it. So by definition, what a vector is a quantity that includes, can you have that on here? Oh, yes, we can. Okay. A vector that includes, is a quantity that includes magnitude. That's not a highlighter, that's a crayon. Never mind. It's a crayon. Okay, a vector is a quantity that includes magnitude and direction. Okay, so anytime we're talking about vectors, it has to have a magnitude and it has to have a direction. If we're just talking about distance, then that's not a vector. So like, for example, in the problem over here, this is not a vector, that's just a distance, okay? All right, so symbolically, when you write a vector, it will be a bold lowercase letter, okay? So if you see a bold lowercase letter, that's a vector. So this is saying that's a vector, okay? And is gonna look kind of like a ray. So like this is how you would visually see a vector. So you have your initial point here, which is where you're starting. You have your terminal over here. Now, the arrow in this case for vectors, it's important to note, the arrow does not mean that it goes on forever. Okay, it's not like domain and range or regular functions. The arrow is just telling you the direction in which you are going, right? Because if you just had 2 points and you said that's the vector, you don't know whether that vector is going this direction or whether it's going that direction. So this arrow here is just specifying and telling you it is going in that direction, but it stops, the magnitude stops right there. Okay, so that's slightly different than the regular functions that we have. Okay, so that's just kind of general. Today's is just intro. What is a vector? Just talking about what is the different features of it. Okay. Pause me at any point if you have any questions on that. Okay. example of a vector, okay? So if magnitude is kind of how long it is, that can be represented in multiple ways, okay? Magnitude could be the speed of the particular thing that we're talking about, okay? So magnitude could be the speed, and then if magnitude is the speed, then the vector is velocity, okay? But magnitude could be a speed, okay? Magnitude could also be a distance. So let's say you're traveling or you walked 5 meters north, then your magnitude is 5 meters. That is the distance that you went or how far something is, okay? Magnitude could also be a force, okay? So that would be like saying if I'm pushing this table at 5 newtons, then the magnitude is the force by which I'm pushing it. It becomes a vector when I say I'm pushing this at 5 newtons in this angle, in this direction, okay? So it's important to note that magnitude is not just the distance. Magnitude could be speed, it could be distance, or it could be force, okay? Here's just a couple of examples of what I mean by vectors and what magnitude is. So if they say an airplane flies east for 200 miles before turning 60 degrees south and flying for 100 miles, you could have an airplane. I'm not even going to attempt to draw an airplane, actually. Let's just say this is our airplane. It flies east for 200 miles. Then in that case, your magnitude is 200, right? And your direction is east, okay? Which therefore makes that a vector because you have a component of magnitude and you have a component of direction, okay? And then turning 60 degrees south, that would be a separate vector. That's this angle 60 degrees, 100. So this is a separate vector in which your direction component is there, 60 degrees. Your magnitude component is there, 100 miles. That's one example of, in the context of distance being your magnitude. This would be a context of force being your magnitude. So let's say you are here and you are pushing this lawnmower, okay? This would be a vector because you have the component of magnitude, which in this case is saying you're pushing it down at 450 newtons. That's the force by which it's being pushed. And then you have an angle here, which is your direction component. So this is considered a vector, okay? An example of speed as the magnitude, let's say this person is hitting a baseball. This 103 feet per second is the speed, the initial speed by which the ball is hit. And then you have an angle which tells you the direction. And so that is a vector because you have a magnitude, which is speed, and you have an angle, which is your direction. And the vector is of the ball being hit. Okay, so that's just kind of general definitions and ways in which we'll kind of use vectors. Okay, any questions thus far? Okay, so there's just a couple of formulas I want to talk about here. That how we would write vectors. Okay, so let's say we have this as vector v here. This is the vector. Okay, I'm gonna remove this a and b. Let's just say it's vector v. Don't want to use the a and b there, so I don't want to confuse when we talk about this a and b. So let's just say we have a vector there. Okay, this arrow does not mean that it goes on forever because we're talking about vectors. That's just telling you the direction in which it is going there. Okay. So the way in which you write a vector is in what you call component form, okay? Component form. Component form is A comma B, but instead of parentheses, you have like the little triangles on the side, triangle looking things. I forgot what they're called, sorry. So this is component form. And so A is your horizontal component. And B is your vertical component. Okay. A is your horizontal component, B is your vertical component. Whenever you write a vector in component form, that is the way in which you would write it. Okay. And so if you were writing the component form of this, you write the horizontal vector A, which is this. Okay, that's your horizontal vector, which in this case you would just count this distance here. So you would just say what the distance is of your horizontal vector. 1, 2, 3, 4, 5, 6. Okay. Then you would write your vertical vector, or sorry, your vertical component of the vector, which is this 1, 2, 3, 4. So by describing the horizontal component and the vertical component as being 6 and 4, you would write the whole vector v as v in component form is 6, comma 4. And this would be how you would write the vector. Okay. So you always have a comma b, a being the horizontal component, b being the vertical component of the vector. And so that's how you would write it instead of like as a point or anything like that. So it would be a comma b. Okay. Now, if you had if you didn't have the graph but you had the points, like let's say you had this point here, and this point is 8, 7. Excuse me. Excuse me. One thing about me, if I sneeze, I never sneeze once. It's really weird. I always sneeze at least 3 times. It's super weird. I don't know why. All right, right here. This one over here is 2, 3. Thank you. Someone said bless. So if you had just the order pairs, let's say I said we had a vector that starts at 2, 3, and then it ends at 8, 7. Instead of graphing every time, you could just do x2 minus x1 will give you the a, right? So you could just do this 8 minus 2, right? And so 8 minus 2 is 6, and so that gives you your a right here. And you can do y2 minus y1. So you could do the 7 minus the 3. That would be 4. That will give you your b right here. Because you're just subtracting, this and this. If you subtract these two, you're just going to get the 6, which is that, right? So you could just subtract the x2 and x1. That's just another way if you just have the points. Okay? Any questions? What was this? This was 6, 4. Okay. All right, so the first thing is component form, so a comma b. Second thing is magnitude. The way that you would see magnitude is it looks like an absolute value kind of, and then the vector, whatever the vector is described as, whatever letter is used, that if you see that, that means magnitude, okay? Magnitude is either, we talked about some minute ago, either the distance, the speed, or the force of the vector, depending on what we're talking about. In this particular case, the magnitude would be described as a distance, a speed, or a force. Let's hear from Kelly. Hey, buddy. We're learning right now. You just want to say hi? The magnitude would be described as a speed, distance, or force. Oh, you want to wear the earphones? Kelly, could you answer that question? All right.
Distance.
Distance, very good. All right, can you go back with mommy, please?
Come here, babe.
All right, awesome.
Come here. Come here.
Sorry. Okay, I'm back. Distance, very good. So how we would find that distance is using this formula, okay? So the magnitude equals square root of a squared plus b squared, okay? And all that really is just the Pythagorean theorem, right? Because if you have a triangle and we're saying that this is A and this is B, and we're trying to find the magnitude, this is our magnitude here, and that's C, it's just A squared plus B squared equals C squared, right? And then to solve that, you would just square root. So that's all that this is just from the Pythagorean theorem, okay? And so if you just want to do the Pythagorean theorem every time and just kind of think about it that way, instead of trying to think about a separate formula, it's really the same thing, okay? So if we were finding the magnitude of this, it would just be the square root of 6 squared plus 4 squared, right? And that would be 36 plus 16, right? So that would be the square root of 52, right? And so that means that this magnitude right here is the square root of 52. And we want to see, could we rationalize that, or not rationalize, could we simplify that potentially? Let's see, 2 and 26, right? Two and 13, so we could rationalize it. So we could simplify it to square root of 4 times square root of 13, right? And then that will be 2 square root of 13. So we could also simplify it. Or you could write it as a decimal, either way. Okay. Let me pause because I talked about a lot of definitions and just different concepts. And let me see if we have any questions up to this point. And even if you don't have questions, you could just send a message or say I'm good. But I just want to make sure we're all good up to this point. All right, so just pause to give you a minute to process. And all right, so far I don't have any questions, so we'll keep moving there. So the other piece here is the direction, okay, which is represented as theta. So that's going to be the direction that the vector is pointing as an angle from the horizontal, okay? As an angle from the horizontal. And the way we're going to find that is using tangent inverse of B over A. Tangent inverse of B over A, okay? So that's because tangent is opposite over adjacent, right? And so let's say we wanted to find what this angle is. This is the opposite, and this is the adjacent, right? And your opposite, this is A and this is B. Your opposite is your B, and your adjacent is your A, and that's always going to be the case. So then for every single time, we can just do, if this is the that's the opposite, and this is adjacent, right? So every single time is just going to be tangent inverse of B over A, because B will always be your opposite, A will always be your adjacent, and to find the angle, you do the inverse. So if we wanted to find this, we would just do tangent inverse of the B is 4 over 6. Right, and that would give us what the angle is. You would need a calculator for that. Tangent inverse of, forgot what it was, 6, what was it? 4 over 6. So 33.6 degrees. That's going to be your direction for that vector, okay? So you have component form, just to refresh what we just talked about. We have component form, which is A comma B. We have magnitude, which is represented as absolute value, which you use the formula square root of A squared plus B squared. And then you have the direction, the angle, which you use tangent inverse of B over A. Now, a couple of things before we talk about an actual problem. You want to be careful of the quadrant. I wrote that in all caps, and I put an exclamation mark there because this is important. So if you have the notes highlighted, okay? what I mean by that is, let's say that your vector was like this, okay? And let's say you're trying to find the angle, okay? And let's just say that, so now we're going down, bottom, down and left, okay? So let's just say that this component right here to the left was -3, okay? And then let's just say going down, it was -2, okay? When you do tangent inverse, okay, to find the angle, when you do tangent inverse of b over a, in this case, it would be tangent inverse of, what was the number? Someone help me out. No, it was negative. What was it? Negative. So our b would be -2, right? Over -3. So that's going to be 33.6. That's actually the same thing simplified. Okay. But the 33.6 is not our direction because we have to be careful of the quadrant. Okay. The 33.6 is this. And it says that the direction vector is from the horizontal. Okay. Meaning, if we were to kind of the coordinate plane, you can think of it as kind of moved. So the angle that you would want to say is, it is this angle. So you would have to do 180 plus the 33. And so if you were doing this one, it would be 180 plus the 33. And so your direction would have to be 213 degrees from the horizontal. That would be how you would describe it. So you have to be careful of the quadrant that you're in, because depending on the quadrant is going to determine whether or not you're going to be adding 180 or not. And so just be careful, very careful of the quadrant, okay? All right, any questions? All right, or actually one more thing I want to talk about here on this slide. This a comma b, for this last one, it was written as 6 comma 4, right? That was our component form. Another way you could also see it represented is 6i plus 4j, and I would write that down as well, okay? And we'll talk about what I and j is. It has to do with coming from the standard position, but for now, just all you need to know is that 6 comma 4 can also be written as this. It's another way to write component form, okay? All right. And then a vector is considered in standard position if its initial point is at the origin, okay? So if the initial point is at the origin, it's in standard position. So like this one is not in standard position. It has to start at the origin to be considered as standard position. So just make sure you write down the 6i and the 4j. That's going to come up in the practice today, actually. All right. Okay.
Mr. T,
Yes.
for the angle, so what quadrant does it have to be for you not to add 180?
Good question. So like, I'm just gonna use this because it's a blank page. So like, if you're over here and you find the component form,
Mm-hmm.
then when you do tangent inverse, it'll just give you the correct angle, right? That's from the horizontal. You don't need to add 180, subtract 180. If your vector is like that, then your component form, this would be your B, or sorry, your A, and that would be your B, right? And so when you do tangent inverse, you'll be getting this angle. But then in that case, your angle from the horizontal is going to be this, right? So in that case, you would actually have to do 180 minus that angle to find what this is. Sorry, it should be to here. I'm sorry, to here, right? That's going to be your angle. You following?
Yeah.
Okay. If you're over here, we just did one like that, right? That was the adding 180. If we're over here, then when you do the component form, that's your A and B. And when you do tangent inverse, you're going to get this angle. So then in that case, this is the angle from the horizontal. So in that case, you would actually have to do 360 minus this in order to get that angle, right? So those would be the 4 main cases. You would only ever be in one of those 4 quadrants. So either it's like this, where it's just exactly the same, you don't have to add or subtract, or it's like this, where you're going to get this angle. And so to find from the horizontal, you'd be looking for this, you would have to do 180 minus that. Or it'd be like the case we did, or it'd be like this case, you would actually have to do the 360 minus, right? Those would be the 4 cases. Does that answer your question?
Yes.
Okay. Other questions? Good question. Okay. All right, so let's try a problem. So let's say we have this point 3, 4 and -4, 1. And it says find the magnitude, component form, and direction of a vector with initial point of 3, 4 and terminal point of -4, 1, right? It would help to get a visual of it. So we could just plot this 3, 4 here, -4, 1. And that's our vector. We're just talking about distance right now. So it's not an application problem. It's just points. And because this is a vector, we need to draw an arrow. And so we're drawing an arrow from 3, 4 to -4, 1, because the terminal point is -4, 1. So it's going like that, right? That arrow, again, does not mean it continues forever that direction. It just means that that is the direction in which it is going. Component form is the one that's A, B, right? A is your horizontal component. B is your vertical component. I'll ask some questions for y'all. Landon, could you help us with finding the A? What would you do to find the A here? It's a couple different ways.
You could just count it on the graph.
Okay, from where?
From the point 3, 4.
Okay.
You could go down 3 and then left.
So let's just do A first. So A is
Oh, okay.
So which way are we going for A?
You would go left for A.
Okay. So that's what?
That's 7.
Okay. So is A 7?
Yes.
Well, be careful though. Which way did we go?
Left.
So it'd be so since we went left, we would have to do, well, A would not be 7, but it would be
Negative.
-7.
Oh, okay. Okay.
And then the B, we're going down, right? So that would be
-3.
Okay, good. All right, so that's our component form. All right. Any questions? We could also do the formula x2 minus x1 and y2 minus y1. That would give us the same thing. All right. Magnitude. Maria, could you help us out with the magnitude? How do you find the magnitude?
For magnitude, you can just do square root of -7 plus, square root of, -7 squared plus -3 squared.
Okay, good. So that's using the formula that a squared plus b squared, right? All right. So that's going to be 49 plus 9. That'll be 58, right? And then we want to see, could we possibly simplify that radical? We could also write it as a decimal, depending on how the problem wants it. It doesn't specify here, so we could leave it like that, simplify it, or we could write it as a decimal. I'm not sure if that can be simplified. Can that be simplified? Let's see. 2 times what gives us 58? 9. 2 times 29. No, I don't think it can. It can't be simplified, so we can leave it like that. All right. All right. Direction. Direction. Let's do Jimena. Could you help us with direction?
We would do the opposite over adjacent.
Okay. Like just what opposite over adjacent like?
Oh, like the numbers.
Okay.
V over A as in like -3 over -7.
Okay.
And then the tangent inverse. But see, this is where I'm confused. Like, would it be like, you know what we talked about, the 180?
Yeah. So let's find what this equals and let's see. So tangent inverse. Of what was it? Negative.
Yeah, -3 over -7.
Okay, 23.1. So we get, right now we have 23.1. So if you want to decide, okay, I'm adding 180, subtracting 180, what am I doing with this? You can put that on the graph that you have, the vector that you have visually. So this 23.1 is the measure of this angle right here, right? That's what you found out because you did opposite over this adjacent. So this is 23.1. What we're finding is the measure of the angle from the horizontal, like if you drew a coordinate grid with this in the middle. So like if we drew that, then the angle that we are finding is we are going from here around until we hit the vector, which is here. So that's the angle from the horizontal, which is this, to the vector, which is this. And so if we were finding that angle, what do you think we would do with the 23.1?
And you would add 180.
Okay, yeah, exactly. So it'll be 180 plus 23.1. So it kind of helps to get a visual because if you see it, then you know whether you're adding 180, doing 360, what are you doing? Alexander, I see your message. Thank you. Okay, so that means that would be it would be 203.1 degrees from the horizontal. Would be the direction of that vector. Okay. Any questions? All right. I want to look at one last thing here. There are no questions. So what about when we're talking about force and when we don't have both of the components? Okay. So we'll read this problem. Carlo, could you read this for us?
pushing the handle of a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. Find the magnitude of a horizontal and vertical component of the force.
Okay, thank you. So we have Heather, okay, over here. This is Heather. And she's pushing this lawnmower, okay? And the force by which she's pushing it is 450 newtons. And the angle from the ground to the handle of the lawnmower, or the bar of the lawnmower, is 56 degrees. And the question is asking for the magnitude, which in this case, the magnitude would be a distance, a speed, or a force. So in this case, the magnitude would be a distance, a speed, or a force.
Wouldn't it be a force?
It would be a force, yeah. So we're looking for the magnitude or the force, just the measurement of the force of both the horizontal and vertical components. So the reason why this has a vertical and a horizontal component is because as Heather is pushing the lawnmower, she is both pushing it forward, but also pushing it downwards. Both are happening at the same time as you push a lawnmower, right? Like if you're standing above some object and you're pushing it, like a lawnmower in this case, you're both pushing the lawnmower forward, but at the same time you're pushing down because of the angle that you have there. If Heather was on the ground, it's Heather on the ground, and the and the handle was like that, and she was pushing it like that, then it would only have a horizontal component because she would strictly be pushing forward. She would not be pushing downward. But because Heather is standing up and pushing the lawnmower, she's both pushing it forward as well as downward. There are two components to the force, okay? So the two components are pushing downward, and this is vector because it's pointing downward. So pushing downward, that is the vertical component of the force. And also pushing horizontally, that is the horizontal component of the force. And what we are trying to find is how much force, because forces are magnitude in this case, how much force is she pushing it downward based on the information we have, and how much force is she pushing it forward based on the information we have. Before we get to that, would there be more force pushing downward or more force pushing, would the force of the A or the B be bigger? Would the force pushing downward or the force pushing forward be bigger? Think about that for a second. Would the force pushing downward or the force pushing forward be stronger in this particular case? Would the force pushing forward or the force pushing downward be stronger in this particular case? All right, let's hear from Sophia. What you got? Would the force pushing downward or the force pushing forward be stronger in this particular case? Sophia, what do you think?
I think pushing forward.
Pushing forward? Okay, why?
Because of the angle.
Okay, so this one right here is what you're talking about. That one will be stronger, right?
Yeah.
Okay, so let's think about this in terms of extremes. Okay, so let's say that the lawnmower. This is a person. Again, bear with me with my drawing, but this is a person pushing it. This is a lawnmower over here. Okay. Oh. Ah. So let's say we have it like that. This is 1 and this is 2. Okay. In this case, is as you're pushing the lawnmower, the because of the angle, the person pushing it is pushing down more than they're pushing forward, right? Like if you kind of think about yourself trying to push something, this person would be pushing downward more than forward because of the way that it is, right? The more slanted it is down, this person is pushing more horizontally than they are pushing vertically, if that makes sense. So if you're looking at this, it is slightly bigger than 45 degrees. So it's a little bit more towards this example. Or you could just look at the actual kind of distances, if you will, just visually. This one is actually going to be bigger slightly. So it's going to be pushing downward is going to be a little bit more than pushing forward. Okay? Does that make sense?
Yeah.
All right, awesome. Okay, so how do we find the exact measurement of those forces? You're going to use this formula here, okay? This represents magnitude, right? Times cosine of the angle, okay? And then magnitude times sine of the angle. That's going to be what we would use here in order to determine the A and the B, or the horizontal component of the force and the vertical component of the force. Let me just show you real quick where that comes from. So if we think about this is A and this is B in component form, right? And we're saying A is magnitude times cosine of the angle, B is magnitude times sine of the angle. So if you have this, which is your magnitude, and let's say you're trying to find this, which we're calling our A, okay? The formula that you would use for this is your adjacent, right? And this is your hypotenuse with respect to this angle. And the relation between adjacent and hypotenuse is cosine. So cosine of the angle equals our adjacent, which in this case is our A, right? Our horizontal component, over our hypotenuse, which in this case is our magnitude, right? And so if we wanted to solve for A, you would just multiply by the magnitude. And so the magnitude times cosine of the angle equals the A, which is going to be this, okay? That's why this A is magnitude times cosine of the angle, okay? That's just showing you why it's like that. For the B, let me erase this. The B is this, okay? And so in this graph, this is our B, our vertical component, and that is the opposite, and this is the hypotenuse. And so sine of the angle is B, which is the opposite, over hypotenuse, which is magnitude. And kind of the same thing happens when you solve, you multiply by the magnitude, you get magnitude of sine of the angle equals B, which is why B is magnitude times sine of the angle. So that's just where those formulas are coming from. It's just kind of just using a regular trig to find A and B, okay? So looking at this, that's just it, and you would have to know that formula. Magnitude times cosine of the angle, magnitude times sine of the angle to find A and B. And this is, no, this is A, I'm sorry, and this is B, right? So it would be, to find A, magnitude, which is 450, times cosine of 56 is the angle, comma, magnitude, which is 450, times sine of the angle, which is 56. That will help us to find the A and the B. Any questions thus far? Okay. So then you would use a calculator for that. 450 times sine of 56 and 450 times cosine of 56. And so, wait a second, did I do something wrong? Oh, no, okay, that's good. 373 and 251. 373. And that is going to be the A and the B. Any questions? Okay. So that means that the force at which is being pushed down, 373 newtons. Force at which is being pushed left, 251 newtons. Okay. So that's how you would find out. All right. Just to make sure that we feel 100% comfortable with that, I want to give you one problem that I want you to try, and then that's the last problem for today. All right. So let's say you have this angle, which is 30 degrees. All right. So let's say you have this vector with a magnitude of 8. This angle is 30. And I want you to write the component form of vector v. I want you to take some time and try that problem. When you have your answer, send it in the chat, please. Okay. So what we should have remembered is that for the component form, which is a comma b, if you have angle and you have magnitude, it would be best to use magnitude of the angle, or sorry, magnitude of the vector times cosine and magnitude times sine. By the way, here's a way that I remember this. This the general component form. I just think about the unit circle. So like in the unit circle, x comma y, x is cosine, sine is y, right? So it's this, I just think about the same thing here. Like if I'm trying to find the a, cosine, comma, sine. I don't know if that helps you, but just a tip. That's how I remember it. Cosine, comma, sine, because x and y in the unit circle is cosine and then sine. So the magnitude we have is 8, right? All right, let me not write the absolute value, just 8 times cosine of the angle. We're going to come back to the angle in a second. And then 8 times sine of the angle. So that would be all, really all you need to do is just use that formula, plug in. The key thing here that I actually wanted you to try first before we talked about it is recognizing what your angle is going to be. That's the biggest part. What do we put for our angle? If you put 30 degrees as the angle, if you put 30 here, it's going to mess you up later with your negatives, okay? The reason why that is because if you put 30 degrees here, then what you're telling the calculator, if you put in the calculator, is that your triangle has an angle of 30 degrees. And so therefore you're only going to be finding these values with this triangle in the first quadrant, okay? But even though this is 30, the calculator has to be able to recognize I'm actually going around past, we're not just in this 30 right here, right? Because if you use that 30, you're always going to get positive values. Or if you use that 60, you're always going to get positive values. So it's important to know what quadrant you are in. That's kind of what I was talking about earlier. So because we're all the way over here, we can't just use this 30, okay? If the vector was over here, and this was 8, and then this was 30, then yeah, we could put 30 right here, okay? But because our vector is over here, we know that our components, this has to be negative, and this has to be negative. And the only way to get negatives is when your angle starts getting bigger than 90. So we're gonna have to use this angle. And so that's why you always wanna use the angle from the horizontal, so that when you plug in for cosine and sine, you're able to get the correct values. And all it's gonna change is the negatives, really. it's not going to change the actual value. It's just going to change the negative. So you can always double check. Let's say you put in 30, you can just look at your and see if your negatives match. If they don't, you can change the negatives. Okay. But the angle we should be using is 210 degrees because it's 180 here and then plus 30. So if you put 210 here and 210 here, you should end up with 8. And we could have used a unit circle here, by the way, right? Because cosine of 210 is negative square root of 3 over 2. Sine of 210 is 1/2, negative 1/2. So it's 8 times negative 1/2, if I didn't want to use a calculator. And then this part on the left will give me negative square root of 3, or sorry, negative 4 square root of 3, because 8 divided by 4 is 2. And this part right here would give me negative 4. If I wanted a clean number with no decimal, I could use a unit circle because 210 is on the unit circle, right? And that's what we would get. If you wanted this as a decimal, I think it was, yeah, negative 6.9 something, I think 2. So that means, and the way you can double check this is you go back here and you look and see, okay, this is A and this is B, so it has to make sense. A is our horizontal component. So does it go left, negative 6.92, and then does it go down for negative 4? Yes. And so you just want to be careful with the negatives. If you put 30 in here and 30 in here, you probably ended up with 6.92 comma 4. And then if you did that, you go back and you look at it, you can see, okay, 6.92 comma 4 would be over here. So you just would have to fix your negatives. Okay. Any questions on that or the vector lesson? Again, this is just an intro lesson. What is component form? What is a vector? What is magnitude? What is the angle? How do you find it? Next week, we'll look at multiplying, adding, subtracting vectors, and then we'll look at situations, applications. That's where we're headed with vectors. Any questions, comments?
The practice for today is on IXL, right?
It is, yes. So let's talk about that. So it's on Google Classroom if you haven't seen it yet. There's a username and a password for IXL, okay? Which you can just find your name, then username and password. You can change your password if you want. So if you've never used IXL, I'm going to show you how to navigate it. But you're going to be doing U.I, U.2, U.3, and U.4. IXL is a software in which you work at your own pace. So there's not a specific set number of questions you have to do. Based on how many questions you do, it's just like if you get them right, your points increase fast, and then you get a score. There's an infinite amount of questions, but you only have to do as much as you want to get the grade that you want. There will be a plus 10 curve, okay? So if your score is an 80 plus 10, your score is a 90, okay? And there's opportunity for extra credit. So these are just the 4 topics, and I posted them on Google Classroom, U.I, U.2, U.3, U.4. So let me just show you, if you've never used it, how it works, okay? So you will go to the website, and there's an app, I believe, I'm not sure, I know there's an app for iPhone, I'm not sure if there's one for Android, but I believe there is. So you can download the app. It's a lot easier and cleaner to work than online. So IXL is the app. You would log in up here with your username and your password that I posted, okay? And then you would go to math, or I'm already math. If you had the app, it would be easier to navigate. Then you would go to pre-calculus. Okay. And there's a bunch of topics here. So you would just find U, that's what, U.1. So like here, U.1, find the magnitude of the vector. Okay. So I would just click that. And on the app, you could search U.1 and it'll come up. And then it basically shows you this. And so over here, it says find the magnitude of the vector. Write your answers. This will be an easy one. You just count. This one, I'm going to say the magnitude is 10. Submit, and it'll tell me I'm right. Right. This is just quick questions on just the kind of concepts we just talked about. So this would be 8. And you can see as I'm doing it, I haven't logged in, so eventually it won't allow me to go anymore. But if you look on over here, I can't point on this because it's internet, but on the bottom right where it says smart score out of 100, that's going to be the score, and that you would add 10 to. But you see, it takes you up fast if you get them right. But let's say like I get this wrong and I put the answer as 2, then my score will go down slightly, and then it'll give me an explanation as to how to do the problem if I messed up on it. And take note that they do want it simplified in the radical simplified. If you don't put the simplified radical, if it can be simplified, then it will mark it wrong. So that's IXL. There's so again, you go to IXL, you log in. There's an app for it. You're just doing U1 through U4. I just think they have a good number of questions and good source of questions for vectors. That's why I wanted to do it. I used to use it in past years with my classes. So that's what you'll do for the grading purposes. What you'll do on Google Classroom is you'll take a screenshot of your answers, or not your answers, sorry, your screen. Once you're done, once you're satisfied with your SMART score, you'll take a screenshot of that. You'll upload the 4 screenshots, and you'll calculate the averages. So let's say you got like a 90 on this, an 80 on this, a 70 on this, a 100 on this. You would add the 10. So you would take a screenshot of each of these. Then you would average these 4. 110 divided by 4. Send me a private comment. You know, you can add a comment on Google Classroom with this number, and I'll look at your screenshot. I'll look at that number, and this number will be what the number that I use for the grade. Okay. Any questions? Have a good one.